Welcome back. I'm glad you came back. We are now talking to Mark Stansfield, Managing Director of Solderstar. How are you?
I'm good, thank you. Thanks for inviting me.
I know you had that look like you need to get off your feet. So
I certainly do.
Here we are, yes. Your company makes profiling equipment, oven profiling equipment.
That's correct, yeah.
That is a little different than what I would consider a stereotypical profiler. But before we get into that difference, I just want to establish that one of the things, which is part of the difference that your product can do, besides normal profiling things, is measure nitrogen levels. So before we just talk about that, explain to me and my audience why in a reflow oven people are inerting it with nitrogen. Why do they do that? What benefit does that provide? And then we'll get into kind of the tech on how
we do it.
The value of monitoring it.
Yeah,
right?
of course.
Let's tell us why it's there in the first place.
Yeah, well, there's a number of reasons to use nitrogen. The main one really is we're looking to reduce the amount of oxidization in the process. Whenever you've got heat and metals in the same place, then inevitably there will be some level of oxidization. Now, we're not actually removing the oxidization, that's the job of the fluxes within the solder paste. But what we can do is, by inerting the process and reducing the concentration of oxygen there, we can actually slow down any oxidization or certainly minimize it, which is a big benefit. The second reason is we improve wetting, so we get nicely soldered joints.
So in a wave solder machine, for example, maybe less bridging?
Yeah, certainly.
Does it play with, surface tension may not be the right
No, that is the right
term. In that context also? Okay. Does it lower the surface tension?
It does indeed, yes, which leads to other problems actually. It's not just
solve
the
one
lower
problem, get another.
It's not the lower the ppm the better, that's not the case, because if we go too low, then in reflow we get problems with tombstoning and things like that. So it's important we get the level right. You know, we save money by not driving too much nitrogen in there and having too high a flow rate.
Great, you just gave me a good segue. Now we understand why people are using nitrogen, the benefits of it, and what happens if you don't use it in the right volumes or in the right concentrations or whatever. So nitrogen is measured in a machine in like a part per million ppm standard, and there are different ppm availabilities of nitrogen. If you're generating your own nitrogen, that may be adjustable. If you're buying nitrogen, delivered in a big tank, maybe you just predetermine what the ppm is. I'm not sure if it changes as it's delivered, but you need to get it right. Now, profilers historically, my understanding of profilers historically are just measuring, they're thermocouples. They're just fancy thermocouples, lots of them in various places of the board. And then there's algorithms that can track predictions and ramps and all this stuff. You end up seeing this pretty cool graphic chart of the temperature. You're adding a different dimension to that. You're adding the ability to measure O2.
Yeah.
Why hasn't that been done sooner? First of all, I'm not going to put blame on everyone else. Why didn't you guys do it sooner?
Yeah.
Why hasn't the industry really embraced it sooner? Is the tech so new that you've discovered a way to do it and package it to be able to have that kind of sensor in an extremely hot environment? Or what were the challenges?
It's quite a difficult thing to do actually. It's actually the culmination of a 3-year development program. We measure thermocouples, of course. That's core to every thermal process is the need to measure temperature. But we embarked 3 years ago on the development of a new data logger, which we call the Solderstar SLX. The X stands for expandability, and what this allows us to do, it gives us the performance and communication methods to add advanced sensors to it. So not just temperature, we can measure vibration on the conveyor, we can measure vacuum levels in the vacuum chambers that you'll see now on some reflow processes, and then the final piece in the jigsaw was the ppm level for people who are using nitrogen. And we've been asked numerous times over the years, and it has proved quite a labour of love to get there. But we are there now, and we've got basically a single pass instrument that can measure all those parameters, give the engineer instantly all the data he needs.
So someone may make a decision to purchase a product like yours just for the nitrogen measuring capability. Possible. Let's talk about the other stuff that's already in there, which is the ability to measure temperature and an actual profile, thermal profile aboard. Are there any advancements in that realm as well? Has that product line as an industry matured to the point where pretty much all the profilers have very similar capacities and benefits
to
maybe
some extent, yes,
on the extreme edges?
To some extent. Usability is a key thing. Our new
User interface and
well, more the instruments actually. People have said for many years it's all about the software, hardware's the same. I've heard that many times in the last 25 years.
That depends on which side of the factory they sit on.
Yeah, maybe. Our new Datalogger is pretty neat. We don't need a computer to set it up. We're trying to streamline the whole process. You can just walk up to the machine, connect it to your fixture, detects all the sensors, all the thermocouples, shows the engineer if they're good or bad, because these things break from time to time, they're quite fragile. And then you can just press the button and go through the machine. So there's no apps, there's no need for a computer. We just want to get data from the machine as quickly as possible. Of course, we still download to a computer. We still need to do that to make the analysis. We've got some pretty nice tools. You know, we have integrated SPC, because there's two functions for these devices. One is the setup and optimization of the process. But once that's performed, many of our customers want to do daily checking of the process, or when there's a batch change to different PCBs. So they have some real nice historical data to do SPC trend analysis and things like that. Yeah.
Right. Excellent. And is this oven, the O2 sensor, not something that's already in reflow ovens from the factory, or is it already there but you're doing it better, or you're combining other value addeds with it, or is it missing from the equation altogether, largely?
No, most machines have a single point of measurement at one point in the machine.
Okay, which may not be representative of certain areas.
We specialize in measuring at product level. That's
as it travels through.
Same with the temperature, same with the O2.
That makes sense.
And there's many reasons why it goes wrong. You know, it shows quite a few things actually. Different machines have different nitrogen designs. Some are feeding in from a single point, the nitrogen. Some are feeding in from both ends of the machine. And you pass the shuttle through, you'll see immediately the benefits of both of those designs. There's lots of seals that degrade. So when the PPM's not right, it's really difficult to find out where that problem is. It's expensive to maintain those machines. And you've got to change every seal.
All you know is it's not right here. You don't know where the offending area is.
Yeah, the key difference is we're measuring zone by zone, so we see exactly where in the machine any problem may lie.
It goes through zone 4 and spikes or dips, then you know
it's a big time saver.
Something around there. Yeah. Excellent. And has it been received well so far?
Extremely well, yeah.
Good.
Yeah.
Well, Mark Stansfield, thank you for being my very short time guest today on this abbreviated version of Reliability Matters, a little tapas bar of subject matter experts. Thanks for being here, and I wish you all the luck in the world, and you probably don't need the luck, but good success to you on this new product launch.
Okay, thank you.
Take care.